We are going to start now the chapter 13 of class 9th mathematics. It is surface area and volumes, and we have divided this chapter in 4 lectures. So we are going to start our first lecture now. Now first of all, we have some definitions over here, and the first definition that we have is the definition of a solid. So body that occupy space are called solids, and they can be of various forms, and in this chapter we are particularly interested in some particular objects that are in the form of cuboid, cube, cylinder, cone and sphere. We will see the definitions of these objects and shape of these objects, and we will study the surface area and volumes of these objects. Now the next definition we have, it is volume of a solid. So the space occupied by a solid body is called its volume, and its units are cubic centimeters. The volume that is measured, it is in terms of cubic centimeters. We also write this as centimeter cube, or we can write it as cc. Similarly, if the lengths they are given in terms of meter, then we write it as meter cube, and we call this as cubic meters. The units we call it as cubic meters. The next definition we have, it is a cuboid. So a solid bounded by 6 rectangular faces is called a cuboid. So if we talk about the example of cuboid, then the matchbox we have, the chalk box, a brick, a tile, a book, all these are examples of cuboid. So we are saying it has basically 6 rectangular faces that are joined with each other. It is a solid bounded by means it is a closed object, and it has the 6 faces, and all these 6 faces, these are rectangles. So in this figure we have shown how a cuboid looks like, and we are saying these are the 6 faces it has. The 6 faces we are saying, this front face we are talking about, it is A, E, F, B. Then behind this is the face D, H, C, G. Similarly, on this side we are having this face over here, that is F, G, C, B, and this is the face E, H, D, A. Then on the top and bottom we have 2 faces over here. One is E, H, F, G, F, and one is A, D, C, D. So these are the 6 faces of this cuboid. And the top, after leaving the top and bottom faces, we are left with 4 faces, and those 4 faces, these are called the lateral faces. Then we are having edges over here. Edges we are talking about this A, B is an edge. Similarly, this B, C is an edge. So we have total 12 edges in a cuboid, and then these points we are talking about, this point A, this point B, this point C, where these edges they meet each other. These points, these are called the vertices. These are the 8 vertices of the cuboid A, B. These vertices we are naming it is A, B, C, D, E, F and G and H. These are the 8 vertices. So a rectangular room is in the form of a cuboid. It has 4 walls and are its lateral faces. The 4 walls we are saying, these are the lateral faces. The roof and the floor, they are not the lateral faces. This is the definition we have, that the 4 walls we call them as the lateral faces. Next is a cube. A cuboid, this is the definition over here, the definition of cube. We are saying a cuboid whose length, breadth and height are all equal is called a cube. So basically we are saying that when we are talking about cuboid, it is made up of rectangular faces, and when we are talking about the cube, it is made up of the square faces. All the faces they are square. So the example they are given over here, some dice, when we look at sugar cubes, when we look at these, all are the examples of cubes. Not all sugar cubes, but if all the sides they are equal in length, then we are saying that it is a cube. So this is given written over here, that each edge of a cube is called its side. Now next we have to find the volume and surface area of the cuboid. So first of all, we are talking about the volume. So if a cuboid is given to us, this AB, we are saying this is the length of the cuboid. This BC, we are saying this is the breadth of the cuboid. And this FB, this length, this is called the height of the cuboid. So if we look at the rectangle at the bottom, this ABCD rectangle we are talking about, the area of this rectangle is length into breadth, and this is the height of the rectangle. So if we multiply this area with this height h, and multiplying it with into h, then we are saying that this is this total value L into B into H, this is the volume of the cuboid. This is the formula for the volume of the cuboid. Now the next thing that we have to calculate is the length of the diagonal of the cuboid. So we are talking about these two faces over here. This is the length L and this is the breadth B. So if I look at this rectangle A, B, C, D, then we are joining these 2 points A and C. Now this A, B, C is the right angle triangle because this angle at B will be 90 degree. So length of this AC, the length of this AC will be square root of L square plus B square. Now if I join A and G, I am joining these 2 points A and G. So I am talking about the triangle now. The triangle I am talking about is A, G, C, this triangle. Now in this triangle, we are saying this GC is the height. The length of this AC is this. Then the length of this side over here, this AG, it will be square root of H square plus square root of L square plus B square whole square. So this square root and square gets cancelled, and what we are left with is that the length of the diagonal is L square plus B square plus H square whole square root. Next is the total and lateral surface area. Lateral surface area is the area of the 4 walls. Both these values, these are same. Lateral surface area means that we are talking about the area of the 4 walls of the cuboid. We are not talking about the floor and the ceiling, or we are saying we are not talking about these two portions. We are talking about the 4 walls. So if we look at this wall A, B, F, E, I am talking about this wall over here. So what we have is, this is the length, this is the height. So area of this wall will be length into height. Similarly, on the back side, there is another wall over here that is DHGC, and for this portion we are saying we are having the same area, that is L into H. So this becomes 2 times L into H. Similarly, we are talking about the two faces. One face we are talking about is EHDA. Now in this face we are talking about, this is the breadth over here, this is the breadth B, and this is the height H. So the area of this region is breadth into height. Similarly, the area over here we are talking about, this portion we are saying BCG D E, oh sorry, we are saying this point we are saying F. This point is F over here. So we are talking about BCGF. So its area is also B into H. So this becomes 2 times B into H. So if we take 2H common, we take 2H common, so we are left with 2 times L plus B into H. This is the area of the 4 walls, and this is also called the lateral surface area. Now if we have to calculate the total surface area, then we are adding 2 portions to it. One is this top portion, the area of this top portion, this is length, this is breadth. So the area of this portion is length into breadth. Similarly, area of this portion over here, DBC, A, B, C, D, this portion over here. Area of this portion is again length into breadth. So it means the value when we add these two, it is 2 times length into breadth. So the total area will become 2 times length into breadth, the area of the 4 walls, and the final formula we get it is 2 times length into breadth plus breadth into height plus length into height. Now if we are talking about a cube, then length, breadth and height. In case of cuboid we are saying L is the length, B is the breadth and H is the height. And in case of cuboid we are saying its edge is A unit. It means L is equal to A, B is equal to A and H is equal to A. So if we put these values in these formulas over here, we are talking about these formulas over here, if we put these values, then we get the volume is A into A into A, it is A cube, cubic units. Then the value of the diagonal will become square root of A square plus A square plus A square. It is square root of A square plus A square plus A square. So it is equal to square root of 3 times A square. So it is equal to root 3 times A. Next, when we are talking about the total surface area, it is A square, A square, A square 3 times into this. So it becomes 6 times A square. And lateral surface area means we are talking about the area of the 4 walls. So that area will be 4 times A square. Now the first question that we have is find the volume, the total surface area and lateral surface area of a cuboid which is 15 meter long, 12 meter wide and 4.5 meter high. So length, breadth and height of the cuboid, it is given to us. It is cuboid. All these values, these are different. So we are saying it is a cuboid. So we have to find the volume. The formula for the volume we have, it is length into breadth into height. So it is 15 into 12 into 4.5 centimeter square. The units over here, it is meter, meter, meter. So the volume will be meter cube. Units of the volume is cubic meters. So when you multiply these three values, you will get it is 810 meter cube. Next, second thing we have to calculate is the total surface area. So it is 2 times L into B, B into H, L into H. Units will be square units. So when we put these values in this formula, we get 2 times 15 into 12 plus 12 into 4.5 plus 15 into 4.5. So basically what you have to do is you have to remember these formulas over here. If you know this formula, you will just substitute the value and you will get the answer as 603 meter square. Now the next question we have the lateral surface area of the this part we have, it is lateral surface area of the cuboid we have to calculate. So the formula now we know it is 2 times L plus B into H square units. This is the lateral area of the cuboid. So the value we get it is 2 times 15 plus 12 length plus breadth into height is 4.5 meter square. And the final answer we get it is 243 meter square. So this is the lateral surface area of cuboid. Now the next question is how many bricks will be required to construct a wall 13.5 meter long, 6 meter high and 22.5 centimeter thick. Now it is important to note over here that the units over here it is meter, meter and these units are centimeters. So we convert these values in terms of centimeter first. So length of the wall we have it is 1350 centimeter. Breadth of the wall we have it is 22.5 centimeter and height of the wall we have it is 600 centimeter. Why? Because we know that 1 meter is equal to 100 centimeter. So when we are talking about say 6 meter, the value will be 6 into 100 centimeter. The answer you will get it is 600 centimeter. So we are talking about a wall over here. The wall is like this we are talking about. And this wall is made up of bricks. This wall is made up of bricks. We are saying like this. So what we have to do is we have to calculate the number of bricks, and the length, breadth and height of the bricks is also given. So basically what we are saying is that this wall is made up of bricks, means if we calculate the volume of the bricks, and volume of the bricks means if suppose there are n number of bricks, volume of one brick is v, small v, then the total volume of this wall will become n into v, and that will be the total volume of this wall. Suppose the total volume of this wall is capital V. So first of all we are calculating the volume of this wall. So for the volume we have the formula length into breadth into height. We have 1350 centimeter, 22.5 centimeter and 600 centimeter. When we multiply these three values we get the answer in this form. Now volume of the each brick we have to calculate. To calculate the volume of the bricks, we have, these are the dimensions of the brick: 27 centimeter, 12.5 centimeter and 9 centimeter. So volume of each brick will be this. So what we have now is, this is the value of capital V, the volume of the wall. This is the value of the small bricks, small v we are talking about, this value we are talking about, small v. So what we have is that n into v should be equal to capital V. So we want to calculate the value of n. So n is equal to capital V over small v. So capital V we have, it is 1350 into 22.5 into 600, and small v we have, it is 27 into 12.5 into 9. So when you solve these values, you calculate these values, you will get the final answer is 6000, and this 6000 is basically the value of the n, that is the number of the bricks that are required. So in this question we are given a room is 16 meter long, 9 meter wide and 3 meter high. It has two doors, each of dimensions 2 meter and 1.5 meter, and 3 windows, each of dimension 1.6 meter into 75 centimeter. So first thing to note over here that except for this 75 centimeter, all other units they are meter over here. So first of all we convert this 75 centimeter to meter, and we know that 1 meter is equal to 100 centimeter. It means 1 centimeter is equal to 1 by 100 meter. So 75 centimeter is equal to 1 by 100 into 75 meter. So the answer we will get for this, it is 0.75 meters. Now we have to find the cost of distempering the wall of the room from inside at the rate of rupees 50 per square meter. So we want to distemper the walls. So to distemper the wall means we are talking about that we have to find the area of walls. We do not want to find the area of the roof and the floor, we just want to find the area of the walls. That means we are talking about the lateral surface area. Next we have to subtract from this area. From this area we have to subtract the areas of the windows, because windows need not be distempered, they are the open spaces over there. So this thing we have to calculate, and we know that the formula for the lateral surface area, it is 2 times L plus B into H. So what is length of the wall? It is 16 meter. What is breadth of the wall? It is 9 meter. And what is height? It is 3 meter. So when we substitute these three values over here, we will get it is 2 times 16 plus 9 into 3. So this is important to note over here that this term, when we are talking about this term, it is 16 plus 9, this is in bracket. So first of all we will solve 16 plus 9, then we will multiply it with 2, and then we will multiply it with 3. So first of all we will solve 16. So why I am telling you this, because sometimes we commit the mistake like this, that it is 16 plus 9 into 3. What we do is 16 into 2, 32. Then we are doing, suppose you can write it like this, then what you do, you add 32 plus 9, but this thing is wrong. What we have to do is, it is 2 into 16 plus 9 into 3. So first thing we have to solve is the bracket. Bracket means we have to solve this term. You will add these two values and the answer you will get, it is 25. Then it is 25 into 2. The answer we are getting, it is 50 into 3, that is equal to 150, and the units is, this is the area, so units is meter square. Then we have area of the two doors. We are given that it has two doors, so we have to subtract this area, and the units of the door are 2 meter into 1.5 meter. So to find this area, we are using the formula 2 into 3 by 2. 3 by 2 means we are talking about this 1.5, we can write it as 3 by 2. Why? Because when we are talking about the door is just the rectangle. Door is just the rectangle we are talking about. So the area of this rectangle will be 2 into 1.5 meter. So there are two doors, so we have multiplied with 2, and the answer we are getting, it is 6 meter square. Next we have 3 windows. We are talking about, we have 3 windows, each of dimension 1.6 meter into 75 centimeter. So the area for this is 1.6 into 75 by 100. And how many windows are there? There are 3 windows, so we have multiplied with 3. So the answer that we will get over here, it is 3.6 meter square. This is the answer. This is the area of the 3 windows. So what we have now is, area of 4 walls of the room, it is 150 meter square. Area of 2 doors, it is 6 meter square. Area of 3 windows, it is 3.6 meter square. Now area which is not to be distempered is this 6 meter plus 3.6 meter. We are adding these two values and we are getting, it is 9.6 meter square. So the area of the walls that is to be distempered is 150 meter square minus 9.6 meter square. So answer we get, it is 140.4 meter square. Now rate of distempering the wall is rupees 50 per square meter. The rate of distempering the wall is rupees 50 per square meter. So what we are saying is, rupees 50 per meter square is that if we want to distemper 1 meter square, I am writing it over here, if we want to distemper 1 meter square of wall, the cost is rupees 50. Now we want to distemper 140 meter square, 40.4 meter square, 140.4 meter square of wall. So the cost will be 140.4 into 50 rupees. And the final answer that you will get on solving this, it is rupees 7020. So this is the cost of distempering the room from inside. Now next we have is, a field is 70 meter long and 40 meter broad. So this thing we have shown in this figure, that the field we have, it is 70 meter long and 40 meter broad. In one corner of the field, a pit in which is 10 meter long and 8 meter broad and 5 meter deep. This pit is dug over here, and this pit we are saying, it is, its depth over here, it is, when we talk about its depth, it is 5 meter deep, and the mud, you can say, that is taken out of this field is evenly spread on the remaining part of the field. So first of all, we have to calculate how much mud will be removed. So that will be basically the volume of this pit. So volume of this pit will be, we are having length, breadth and height. So length is 10 meter, breadth is 8 meter and height is 5 meter. Over here height means we are talking about this depth basically. So depth we are saying, it is representing the height over here. So the volume of this pit that will be equal to 10 into 8 into 5, that is equal to 400, and the units for this is meter cube. All these values, these are in terms of meters, so we are saying the units over here, it is meter cube. So what we have is that this much, this is the volume of the, we are saying this much amount of the mud is taken out of this pit. Now this much mud is to be spread on the field, remaining field. So first of all we have to find the area of the remaining field. So the area of this field, if the area of this whole field, it is 70 into 40 meter square. The area of this pit is 10 into 8 meter square. So area of the remaining region over here, the area of this remaining region, it is, you have to subtract these two values. So when we subtract these two values, we get it is 2800 meter square minus 80 meter square, and the answer we will get, it is 2720 meter square. So this is the area of the remaining field. Area of the remaining field means we are talking about this region over here. This region we are saying this is the area of this region. Now we are talking about that the mud, this much amount of mud is to be spread on this area of field. So if we talk about the total volume over here, how we can calculate the volume? We are saying this is the area of this field. We are talking about the area on which the earth is to be spread. We are talking about the area on which the earth is to be spread into the rise in the field. What this value will give? We have seen, when we have studied the formula for the area of the cuboid, we have seen that how we have calculated the volume of the cuboid. We are saying this is the base of the cuboid and the area of this base is length into breadth. We have multiplied this value with the height and we obtain it is the volume. Similarly, we are saying this is the area of this region and this is basically the height that is it is going to attain, and this should be equal to the total volume of the earth dug out. That is the earth, the mud that we have dug out, its volume should be equal to the area of the field into height. What we want to calculate is, we want to calculate this value, rise in the field. So the formula we get, it is rise in the level of field, that is equal to volume of the earth dug out, this is volume of the earth dug out, upon area on which the earth is spread. This is the area on which the earth is to be spread. So the answer that we will get, it is 400 by 2720 meter. So we have converted the answer into centimeter because the answer we will get, it is in decimal form. So to convert it in centimeter, we have multiplied with 100. This 100 we have multiplied over here. To convert this meters into centimeters. So when you solve these values, you will get the answer is 14.70 centimeters. So this is the rise in the level of the field. So I hope this is clear to you that how we are calculating the volume. Volume is basically the area of the base into the height. Area of the base means this is the base over here, and we have multiplied with the rise in the field means the height that of the field that will change by the amount, that is the rise in the field. So when we multiply both these things, we will get the volume of the earth dug out. Now the next we are given an open wooden box 80 centimeter long. We are saying a wooden box is there, it is 80 centimeter long and 65 centimeter wide and 45 centimeter in height. This wooden box we are talking about, these are the dimensions of the box, and it is made up of the wood that is 2.5 centimeter thick. 2.5 centimeter thick means this thickness we are talking about over here, this thickness over here, this is 2.5 centimeter. So what are the dimensions of the box from the inside? One thing more thing that is given to us is that this box is open. There is nothing is there over here. On this side it is open. Now if we look at the height of this box, what we will get, the height of this box will be this much. This is the thickness of this box over here. This is the thickness of this box. The base is there, that is 2.5 centimeter. So we have to find the internal height of this box. So internal height of this box will be 45 minus 2.5, that is equal to 42.5 centimeter. Similarly, when we are talking about the length of this box, on this side we are saying this thickness is 2.5 centimeter. On this side we are saying this thickness is 2.5 centimeter. So total thickness we have over here, this total value we have over here, it is 5 centimeter. When we subtract 80 and 5, we get that this length from inside, the inside length will be 75 centimeter. The inside breadth will be similarly 60 centimeter. This thing is shown over here, that internal breadth of the box it is 60 centimeter, internal length of the box it is 75 centimeter, and internal height of the box it is 42.5 centimeter. It is important to note over here that we have multiplied this 2 and it is not multiplied over here, because on the top the box is open. But when we are talking about the length and breadth, on both sides we are saying, on this side also and this side also, the thickness is there. But when we are talking about height, only on the bottom area, this area, it has thickness over here. So what we get is, these are the external length, breadth and height, external length, breadth and height. These are the internal length, breadth and height. So volume of the box we have to calculate. So external volume of the box we have, it is external length into external breadth into external height. The CUCM means cubic centimeters. This thing we are talking about, this is CUCM means cubic centimeter. This is also written as CC, or you can write it as centimeter cube. So when you multiply these three values, you will get the answer as 234,000 centimeter cube. Next, we have to calculate the capacity of the box. Capacity of the box means we are talking about internal volume of box. So for internal volume we are using, this is 75 is the length, 60 is the breadth, and 42.5 is the breadth. So answer we get, it is 75 into 60 into 42.5, and the final answer we get, it is 191,250 centimeter cube. This is the final answer that we will get. Now we have to calculate the volume of the wood used. So volume of the wood will be external volume minus internal volume. So external volume we have, it is 234,000 centimeter cube. Internal volume we have calculated 191,250 centimeter cube. So the total volume that we will get, it is 42750 centimeter cube. Now we are talking about the weight of the wood. So it is being given that 100 centimeter cube of the wood weighs 8 gram. So we are saying that 100 centimeter cube of the wood weighs 8 gram. So 1 centimeter cube of the wood will weight 8 by 100 grams. Now it is 42750 centimeter cube of wood. So this will weight 8 by 100 into 42750 grams, and when we multiply this value, it is 3420 gram, and we know that 1000 gram, that is equal to 1 kg. It means 1 gram is equal to 1 by 1000 kg. or we can directly see from this that 1 kg is 1000 gram. So this thing we can write it is 3000 gram plus 420 gram. 3000 gram means we are talking about it is 3 kg. So the answer we will get it is 3 kg and 420 grams. Next we have is the total surface area of a cube is 216 centimeter square and we have to find its volume. So the area of the cube, we know the formula is 6 times a square, where a is the side length of the cube and this value is given to be 216 centimeter square. So when we solve this value, we get a square is equal to 36. This 6 gets divided over here, this 6 will get divided over here. It is 36. So the value of a we will get it is 6. It is positive value we are saying is the length, side length. So we are considering the positive value. So the answer for a we will get it is 6. So the volume of the cube, we know the formula, it is a cube. The value of a we have it is 6. So the volume we have it is 216 centimeter cube. So in this case we are getting that the total surface area and the volume, they are same. This is just by chance. It is not like this that these two values are always equal. This is by chance because the side length that we are getting it is 6 and this thing will become 6 cube. If suppose the side length we get it is 7, then these two things will not be equal. So after solving this question, you cannot say that the total surface area and the volume of the cube is always equal. It is just in this case that these two values, these are equal to each other. Next is find the volume, total surface area, lateral surface area and length of diagonal of a cube. Each of edge measures 20 centimeter. So this 20 centimeter is basically the value of a we have, that is side length. So the volume of the cube that we get, it is a cube, cubic units. So the volume of the cube we get it is 20 into 20 into 20. A cube we know, and the answer we get it is 8000 centimeter cube. The total surface area we have it is 6a square. The formula we know it is 6a square. So you must learn or remember these formulas. So 6a square means it is 6 times 20 into 20. Answer you will get it is 2400 centimeter square. Then the lateral surface area we have it is 4a square. Lateral surface area means area of the 4 walls. Area of each wall is a square. How many walls are there? 4 walls. So answer is 4a square. When we are talking about total surface area, it is 4a square plus the area of the floor and area of the roof. So it becomes 6a square. When we are talking about the volume, we are saying the area of the base, it is a square, and height of over here, the height over here, it is again a. So the total volume is a square into a, that is equal to a cube. So lateral surface area when we solve it is 4 times a square. So the value we will get it is 1600 centimeter square. Next we have to calculate the length of the diagonal. The formula for length of the diagonal, it is root 3 times a. So it is root 3 times 20. If the value of root 3 is not given, you can just leave it like this, that it is root 3 into 20 centimeter. If it is given that root 3 is equal to 1.732, then you have to substitute this value and you will get the answer in the form 1.732 into 20, that is equal to 34.64 centimeters. Next we are given that the lateral surface area of a cube is 324 centimeter square. The formula for lateral surface area, it is 4a square and its value is given to be 324 centimeter square. So we get a square is equal to 81. So the value of a we will get it is equal to 9 centimeter. The value of a we will get it is 9 centimeter. So the volume of the cube we know it is a cube. So it is 9 cube, that is equal to 729 centimeter cube. Total surface area we are talking about. This is total surface area we are talking about. It is 6 times a square. So it is 6 into 9 square. So it is equal to 6 into 9 into 9. That is equal to 486 centimeter square. The next question we have, how many square sheets of colored paper of side 30 centimeter would be required to cover a wooden box having length, breadth and height as 90, 60 and 30 centimeter. So we are saying we are having a wooden box over here and we have to cover the sides of this box with a square sheet whose sides are, there is a colored sheet of paper whose sides are 30 centimeter and 30 centimeter. So we have to tell how many papers we require. So what we mean to say is, suppose this is the colored paper we are talking about. So what we are saying is that we have to use this paper and we have to cover this box. So one paper we have pasted over here, second paper we have pasted over here, third paper we have pasted like this. We have to paste the papers like this. So we have to count how many papers we have to use. So it means what we are talking about is we have to calculate the total surface area of this box, and the area of this paper, area of this square sheet of paper. So how many papers will be used will be that if we multiply the area of this square sheet of paper with the number of sheets required, that should be equal to the total surface area of this box. So what is the area of this square sheet of paper? It is 30 centimeter into 30 centimeter, that is equal to 900 centimeter square. What is the area of this box? The total area of this box, it will be 2 times length into breadth plus length into height plus breadth into height. So when you will solve this value, you will get the answer is 19800 centimeter square. So number of sheets will be, we are saying the area of each sheet of paper is 900 centimeter square. So the formula we get, the number of sheets required will be total area of the box divided by area of one sheet of paper. So the answer we get, it is 22. That is 19800 divided by 900, that is equal to 22. So there are 22 sheets of paper that are required. Next we are saying a small indoor greenhouse is made entirely of glass pans that are held together with tape. So the length, breadth and height they are given to us, it is 35, 30 and 25 centimeter. We have to find the area of the glass. So area of the glass means we have to find the total surface area. In the formula we know it is 2 times length into breadth plus breadth into height plus length into height. I am again repeating this thing, that first of all you have to solve this and then you will multiply the answer with 2. I am saying it is 2 into 35 into 30 plus 30 into 25 plus 35 into 25. First of all, what we are going to do is we are going to multiply these terms. We will get the answer as 1050, 750 and this is 875, and it is plus sign between these three and then it is multiplied with 2. Then you will solve this bracket. This is the common mistake that students do. What they do is they multiply 2 with 35 or 2 with 1050, or what they do is they add 30 and 30, but this thing is wrong. Now when you will add these three values, you will get the answer is 2 times 2675, it is 5350 centimeter square. So first of all we will solve these brackets, next we will solve this bracket, then we will multiply it with 2, and the final answer we will get it is 5350 centimeter square. Next we have to find the length of the tape. So we are talking about what is the perimeter of this top portion. This is just a box over here. We are saying this is 35 centimeter and this is 30 centimeter. So perimeter of this portion is 35 plus 30 plus 35 plus 30. What is the perimeter of this bottom portion? It is again this much portion we are talking about. So what we get is that the length of the tape required for top and bottom portion, it is 2 times L plus B plus 2 times L plus B, and then we are left with 4 edges over here. These are the 4 edges, 1 2 3, and 1 edge will be over here. So these are the 4 edges we are talking about, and the height of this panel, it is 25 centimeter. So we are saying it is 4 times the vertical edges. So the final answer we will get, it is 4 times length plus breadth plus height. So when you will substitute these values, length is 35, breadth is 30, and height is 25 centimeters. So the final answer we will get, it is 360 centimeter. So it is 3 meter and 60 centimeters. These are the two things that we have to calculate. We have to find the area of the glass and we have to find the length of the tape that is needed for all the 12 edges. Now the next question we have, a sweet seller placed an order for making cardboard boxes of 2 sizes. These are the 2 sizes that are given to us. This is one size and this is the second size that is given to us. And it is given that 5% of the total surface area is required extra for all overlaps and the cost of cardboard is this. So we have to find the cost of required for making 200 boxes of each kind. So first of all we will calculate the area of each box. So these are the cuboidal boxes. These are in the form of cuboid. So the area of this box with the dimensions 25 centimeter, 20 centimeter and 5 centimeter, it is 2 into 25 into 20, then 20 into 5, then 25 into 5. This is, we have used the formula 2 times length into breadth plus breadth into height plus length into height. So when we solve these values, we will solve these 3 brackets first, 25 into 20, then 20 into 5, then 25 into 5. We will solve these 3 brackets. Then we will solve this bracket over here, and the answer we will get, it is 2 into 725 centimeter square. So the final answer we are getting, it is 1450 centimeter square. So this is the surface area of the cardboard of each bigger box. Then the next thing we have is the total surface area of cardboard required for 200 bigger boxes. Now what is given to us is that for each box we require 5% that more area of the box for the overlap purpose. Overlap purpose means when we are saying that when we are making the box over here, when we have made the box over here, now we are not cutting the box of this much area, we are just cutting some extra area over here, here, here and here, which can be overlapped on the other side. So these two regions, these will overlap with each other to paste each other. We are saying this much portion that will be pasted on each other. So for this purpose, how much extra box is required? It is 5% of the total area of the box that is required extra. So we are saying the area of the box is 1450 centimeter square. So we require 5% extra. So 5% extra means it is 1450 into 5 by 100 we are saying. So this much portion we require extra. So the total area will become 1450 plus 1450 into 5 by 100. This is for one box. This is total area of the cardboard required for one box. Now how many boxes we require? It is 200 boxes. So we multiplied with 200. So when we multiplied with 200, it becomes 1450. This comes out to be common. It is 1 plus 500 into 200. So it is 1450 into 105 by 100 into 200. This gets cancelled. So we are left with this 1450 into 105 into 2, it is 210. And you will multiply these two values, you will get the answer is 304500 centimeter square. This is the answer we are getting over here. So this is the area of the, this is the total amount of the cardboard, the area of the cardboard required for making 200 large boxes. Similarly, for the smaller boxes, length is 15, breadth is 12 and height is 5 centimeter. When we will calculate the total area of this box, it comes out to be 630 centimeter square. This is the area of the smaller box. Again, we require 200 boxes and each box has require 5% more. The cardboard required will be, the area of the cardboard will be 5% more than the area of the box. So again we are using the same thing, that we are saying 5% extra is required, and we have multiplied both these values with 200 because this is 200 is the total boxes required. That is 200 boxes we are going to make. So in this case the area comes out to be 132,300 centimeter square. So the value of two areas that we obtain, one is 304500 centimeter square, that this is the area of the cardboard required to make the larger boxes. This is the area required to make the cardboard of the smaller boxes. So the total area that we get, it is 304500 plus 132300. We have added these two values and the final answer we get, it is 436,800 centimeter square. So this is the total surface area of the cardboard required for 200 boxes of each size. It means this is total 400 boxes we are talking about. 200 smaller boxes and 200 larger boxes. This is the total cardboard required. This total cardboard required also include the 5% that is extra required. The cardboard extra required for making these boxes. Now the cost of cardboard is, that is given to us, is that for 1000 centimeter square, for 1000 centimeter square the cost is rupees 5. We are saying for 1000 centimeter square the cost is rupees 5. For 1 centimeter square the cost will be 5 by 1000 rupees. Now cost of cardboard for 436,800 centimeter square, that will be 5 by 1000 into 436,800 rupees. So when you solve these values, you will get, it is the answer you will get, it is 2184 rupees. So this is the cost of the cardboard required for making these boxes. Now the next question we have is, a man wants to make a temporary shelter for his car by making a box-like structure that covers all four sides and the top of the car. Now if the height of the shelter is 2.5 meter and its base dimensions are 4 meter and 3 meter, how much tarpaulin would be required. So tarpaulin basically it is kind of the shelter cloth, you can say, or plastics, you can say. It is kind of cloth we are saying. So what we are talking about over here is that he wants to make the shelter. So to make the shelter means that what kind of structure will be that? It will be some structure like this. Now the cloth that he is going to cover this shelter, it will cover this portion, it will cover this portion, it will cover the top, and it will cover these two sides also. But the cloth is not required at the bottom. So the area that we require is that, except for the bottom, we do not require this area, but we require the area of the four sides and the top. So the area of the four sides, we are saying it is 2 times L plus B into H. This thing we are talking about, it is lateral surface area, and area of the top will be length into breadth. We do not require the cloth for the bottom part or the floor, we are saying. So the area of the total tarpaulin that is required, it is 2 into 4 plus 3 into 2.5 meter square. This is 2 times L plus B into H, plus we have 4 into 3 meter square. Now again, first of all we will solve this. 4 into 3, it is 7. Next it is 2 into 7, it is 14. Then 2.5 into 14, it is 35. Similarly 4 into 3, it is 12, and the final answer we will get, it is 35 plus 12 is equal to 47 meter square. This is the area of the cloth that is required to make the shelter. Next we are given a cuboidal box, each edge 10 centimeter, and another cuboidal box is 12.5 centimeter long, 10 centimeter wide, and 8 centimeter height. So this box is basically the cubical box, and this is the cuboidal box we are talking about. Then we have to find which box has a greater lateral surface area and by how much, and second, which box has a smaller total surface area and by how much. So we have to find the lateral and the total surface area of both these boxes, and the formula we know for the cuboidal box, the lateral surface area, it is 4 times the edge, and for the lateral surface area of the cuboidal box, we are saying it is 2 times length into plus breadth into height. So when we substitute these values in these two formulas, we get the answer as the lateral surface area of the cuboidal box is 400 centimeter square, and the lateral area of the cuboidal box, the cubical box, we have 400 centimeter square, and for the cuboidal box we have it is 360 centimeter square. So what we see is that the lateral surface areas, the difference of the lateral surface areas, it is 40 centimeter square. So we are saying that the lateral surface area of the cubical box is larger than the cuboidal box by 40 centimeter. So we just have to calculate the lateral surface area. Similarly, in the second part, we have to calculate the total surface area. Total surface area we know it is 6 times A, and this is 2 times L into B, B into H plus L into H. Again, when we substitute the values in these two formulas, we get it is 600 centimeter square, and this is 610 centimeter square. So what we see is that the total surface area of the cuboidal box is smaller than the cubical box by 10 centimeter square. Next, it is given that Kunal built a cubical water tank with lid for his house with each outer edge 1.5 meter long. he gets the outer surface of the tank excluding the base covered with square tiles of side 25 centimeter. Now, how much would he have to spend for the tile if the cost of the tiles is rupees 540 per dozen? So one thing we have to see over here, that this unit it is meter, this unit it is centimeter, and what this doesn't mean? Doesn't means we are talking about that the cost of 12 tiles is 540 rupees. So what we want to find is, we want to find the number of tiles that he has to use to cover it. And if we are able to find the number of tiles, then the cost of 12 tiles we know it is 540. So we can find that how much amount he has to spend on the total amount that he has to spend. So what is given to us is that except for the base he has to cover it with tiles. So it means we have to find the area of the 5 faces, that is the 4 walls and the roof. We have to find the area. So length of the tank that we have, it is 15 meter. 15 meter, when we convert it to centimeter, it becomes 150 centimeter. The breadth will be again 150 centimeter, and the height will be 150 centimeter. So the total surface area of the 5 walls we are talking about, the area of one wall will be 150 into 150, this is for one face. Now how many faces we have? 4 walls and the roof. So there are total 5 faces. So this is the total area that he wants to cover with the tiles by 5, because it is 4 walls and the roof. He doesn't want to attach the tiles to the bottom of that tank. So we are saying it is 5 into 150 into 150. So this is the total area that is to be covered. Now what is the area of each tile? Tile is a square tile. So area of each tile, it is 25 into 25. So how many tiles are required? So to find the number of tiles required, we are saying it is surface area of 5 faces over area of each tile. So when we divide these two values, it is 5 into 150 into 150 over 25 into 25. The final answer that we will get, it is equal to 180. So this is the number of tiles that are required. Now it is given that the cost of 12 tiles is rupees 540. The cost of one tile is 540 by 12, and cost of 180 tiles is 540 by 12 into 180. This is the cost of 540 tiles. So when we will solve this value, we will get the answer is rupees 8100. So this is the cost of total amount of money that he has to spend for the tiles. Now the next question is, a solid cube of side 12 centimeter is cut into 8 cubes of equal volume. So we are saying a cube is given to us, and the side of this cube, it is 12 centimeter. So what is the volume of this cube? It is 12 cube. You know that the volume of the cube is a cube, that is a is the side, then a cube is the volume of the cube, and it has to be cut into 8 cubes of equal volumes. So cutting 8 cube means that the volume of the individual small cube, it is 12 cube by 8 centimeter cube. This is the volume of the each individual smaller cube. Now what we have to do is, what is the side of the new cube? So side of the new cube means this is the volume of the new cube. So side means we are talking about, let its side be a, then a cube is equal to 12 by 2 cube. So this gives us a is equal to 12 by 2 is equal to 6 centimeter. So the value of A we get it is 6 centimeters. So the side of the new cube is 6 centimeter. Also find the ratio between their surface areas. Now we are talking about the surface area of the bigger cube. Its side is 12. So its surface area is 6 times A square. And now its size is 6. So its surface area is 6 times 6 square. So ratio of these three means we are talking about 6 into 12 into 12 over 6 into 6 into 6. So these two 6 gets cancelled. This is 2, this is 2. So it is 4:1. So the ratio between their surface areas is 4:1. So these are the things we have to calculate, that what is the side of the new cube, it is 6, and what is the ratio, it is 4:1. Next is a river 3 meter deep and 40 meter wide is flowing into the sea at the rate of 2 kilometer per hour. So we are given that the river that is given to us, its breadth is 40 meter wide and its depth is 3 meter deep, and the water that is flowing into this is, suppose it is sea, and this is the a river we are saying. So the rate at which the water is flowing, it is 2 kilometer per hour. So how much water will fall into the sea in a minute? So we are talking about that we have to calculate the volume of the water. We have to tell the volume of the water that will flow into the river in 1 minute. So we have to see how much the water will move in 1 minute. So the speed of the water that is given to be 2 kilometer per hour. So how much distance it will travel in 1 minute? We have to calculate this. So it is, we are saying in 60 minutes 2 kilometer distance water is moving. So in 1 minute it is 2 into 1000, we have converted into meter, and it is over 60 meter distance that the water will travel. So the answer for this we will get, it is 100 by 3 meter. So what this thing means is, if suppose we put a clock over here and we start this clock for 1 minute, we have started the timer for 1 minute. We are talking about at this point it is 0. 100 by 3 meter distance is over here. Suppose this is 100 by 3 meter distance. Now when the clock will start moving and 1 minute will be completed, the water that is over here will reach at this point and it will flow into this. So how much water will flow into the sea in 1 minute? That is the water in this much region. The water in this much region will fall into this sea in 1 minute, and we have to find the amount of the water in this much portion. So the amount of water in this much portion means the length now we have, it is 100 by 3 meter. The breadth now we have, it is 40 meter, and the height we have, it is 3 meter. So what is the volume of the water we have? It is 100 by 3 into 40 into 3, that is equal to 4000. This 3 gets cancelled, meter cube. So this is the amount of water that will fall into the sea from the river in 1 minute. Next we are given the length of a cold storage is double its breadth and its height is 3 meter. So height is 3 meter means value of h is given over here. Suppose the breadth of the cold storage is x meters. Then we have its length is 2x meters and height is given to be 3 meters. If the area of its 4 walls is 108 meters square. So what is the formula for the lateral area? It is 2 times L plus B into H. So it is 2 times length is 2x plus breadth is x into H is 3, and this value is given to be equal to 108 meter square. So what we get is, it is, this term will become 3x, so it is 2 into 3x into 3, that is equal to 108. So we get it is 18x is equal to 108. So the value of x we will get, it is 108 by 18, and we know that 18 6 is 108, so it is x is equal to 6. So what is the length of the breadth? This x is basically the breadth of the cold storage. So breadth comes out to be 6. So length comes out to be 2 into 6 is equal to 12 meters. Breadth is 6 meter. Height is given to be 3 meters. So the volume of the cold storage that we have, it is length into breadth into height. So the answer we will get, it is 12 into 6 into 3 meter. So the final answer we have, it is 216 meter cube. Now next we have a village having a population of 4000 require 150 liter of water per head per day. It has a tank measuring 20 meter into 15 meter into 6 meter. For how many days will the water of the tank last? So we are saying that the amount of water required is 150 liter of water per head per day, and 400 persons are there. So total amount of water that is required is 4000 into 150 liters. Now what is liter? 1 liter is equal to, we are saying it is 1 by 1000 meter cube, or what you should remember is that 1000 liter, that is equal to 1 meter cube. 1000 liter is equal to 1 meter cube. So 1 liter is equal to 1 by 1000 meter cube. So how much water that is required per day? It is 4000 into 150. So in place of liter we are writing it is 1 by 1000 meter cube. These gets cancelled and we are left with this 600 meter cube. This is the consumption of 4000 persons per day. Now the measure of the tank is 20 into 15 into 6 meter. So the volume of this tank will be 20 into 15 into 6, that is equal to 1800 meter cube. So per day requirement is 600. So how many days it will last? It is this much water is required per day. This much is the total water we have, and this is the total the water required. This 1800 is the total amount of water stored in the tank, and this is the per day requirement. So how many days the water will last? We will divide these two, and the answer we will get, it is 3 days. So it means if the water tank is filled, then the water will last for 3 days. We are saying a room is half as long again as it is broad. So suppose we are saying the breadth of the room, it is x. So it is half as long again. What this thing means? That it is x meter broad, then it is plus x by 2. This is the length of the room that is given to us, and this value is 3x by 2 meter long. So it is x meter wide and 3x by 2 meter long. Then it is given that the cost of carpeting the room is rupees 13 per meter square, and at this cost the total amount that is to be spent is 702 rupees. Then cost of papering the walls at rupees 7 per meter square is 1204 rupees. If one door and two windows occupy 8 meter square, then we have to find the dimensions of the room. So if the cost of carpeting is rupees 13 per meter square, we have to find the total surface area of the floor. So the total surface area of the floor will be 3x by 2 into x meter square. This is the area of the floor. And what is the cost of carpeting the room? It is at rupees 13 per meter square, and the final answer that we are getting, it is 702 rupees. This is the total cost that we will have. So what we get is that x is equal to x square is equal to 702 into 2 by 3 into 13. On solving this, we will get this is equal to 36. So the value of x we will have it is 6. So it means that the breadth of the room is 6 units and the length of the room is, it is 3 into 6 by 2, that is equal to 9 meter. This is 6 meter and length is 9 meter. Now we have to find the cost of papering the walls. So let the height of the room be h meters. We are saying the height of the room is h meter. So what is the total area of the walls that we have to calculate? So it will be 2 times L plus B. L plus B means we are talking about 9 plus 6 into H. This is the total area of the walls and this comes out to be, this is 30 H meter square. Now it is given that one door and two windows occupy 8 meter square. So the area on which the papering is required is, we are saying it is 30H is the area of the wall, total area we are talking about, and out of this the windows are in, windows and door we are talking about, it occupy 8 meter square area. So we are left with 30H minus 8 meter square of area. Now the cost of papering the walls, it is 7 rupees 7 per meter square and the total cost is equal to 1204 rupees. So when we solve this value, we get it is 30H minus 8 is equal to 1204 by 7, that is equal to 172 meter square. So this value will become, I'm solving this over here. So it is 30H is equal to 172 plus 8, that is equal to 180. So the value of H we will have, it is 180 by 30, that is equal to 6 meters. So what we have obtained is that the length of the room is 9 meter, breadth of the room is 6 meter and height of the room is 6 meters. And this is what we have to find. We have to find the dimensions of the room and they are 9 into 6 into 6 meters. Next we have water flows in a tank 60 meter into 40 meter at the base through a pipe whose cross section is 2 decimeter by 1.5 decimeter at the speed of 8 kilometer per hour. In what time will the water be 5 meter deep? So we are talking about the water flows into the tank that is 60 meter into 40 meter. So this tank is given to us and we are saying, so this is the tank we are talking about and its dimension is 60 meter and on this side it is 40 meter. On this side it is 40 meter and the pipe that is given to us, its dimensions are, this is 2 decimeter and 1.5 decimeter and water is flowing into this tank. The water is flowing into this tank at the speed of, the water that is flowing into this tank, it is at the speed of 8 kilometer per hour. So we have to find in what time the water will be 5 meter deep. So it means we are talking about, we have to calculate the time in which we will get the depth of the water. This tank is filled and what is the height of this tank after? This is 5 meter deep. So the volume of water in this tank, when it is 5 meter deep, the volume of the water will be 60 into 40 into 5. This will be the volume of the water, this much meter cube, and we have to see that in how much time this much water will flow from this pipe. So to find this, we suppose that it takes X hours to fill this tank up to 5 meter. So the volume of the water flown in the tank in X hours, it will be, we have to convert this decimeter into meters. So to convert the decimeter into meter, it is 1.5 by 10 and this will be 2 by 10 meter. So we are saying the amount of water that will flow in X hours we have to calculate. So amount of water that is flowing in X hours, we are saying the distance it is traveling is 8 kilometer per hour. That is, in 1 hour the water is traveling 8000 meter. So in X hours the water will travel 8000 into X meter. It means we are talking about this portion over here, that this is 8000 into X meter of water that will flow over here. So we have all the three dimensions now. This is the length, breadth, this is the length, 8 by 10 is the breadth, and 1.5 by 10 is the height over here. So the amount of water that will flow over here, that will be 2 by 10 length, then 1.5 into 10, that is height over here, and this 8000 into X, this is telling us the length of this pipe, or we are saying the amount, the how much water has traveled in X hours. So this is the volume of the water that has traveled in this pipe in X hours, and that should be equal to 60 into 40 into 5, that is the amount of the water in this tank. So when we solve these values to find the value of X, we are getting it is 240. X is equal to 60 into 40 into 5. So the value of X we will get, it is equal to 50, and X we have considered, it is the X is the time in hours that is required to fill the tank up to the height of 5 meter. So we get that the time required is 50 hours. So in 50 hours this tank will be filled up to the height of 5 meters. Now next we have a storage tank is in the form of a cube. When it is full of water, the volume of water is 15.625 meter cube. If the present depth of water is 1.3 meter, we have to find the volume of the water used from the tank. So we are saying this storage tank is given to us, and the total volume of the water present in it, it is 15.625 meter cube. So we suppose that the length, breadth and height of this cube, it is A. So what we have is that A cube, that is equal to the volume of water, that is equal to 15.625 meter cube. So 1.625 meter, you can write it is 15625 over 1000. When we simplify it, we get 125 by 8, and this value is equal to 5 by 2 whole cube. So the value of A that we get, it is 5 by 2, that is equal to 2.5 meter. This is the dimension of the cube. Now it is given that the present depth of water is 1.3 meter. Present depth of water is means suppose the water is up to this level now. The water is up to this level now. So present depth of water means now the depth of this is 1.3 meter, and we have to find the volume of the water used from the tank. So present volume of the water will be, we are saying the length is now A, the value of A that we have obtained, it is 2.5. So length will be 2.5, breadth will be 2.5, and this is 1.3 meter. So the answer we will get, it is 2.5 into 2.5 into 1.3. So to solve this, we are getting it is 5 into 5. This 2.5 we are writing it is 5 by 2. 5 by 2 into 13 by 10. So it is 65 by 8 meter cube, and the answer we are getting, it is 8.125 meter cube. So the volume of the water used will be, this is the actual volume when the tank was full. This is the volume of the remaining water over here. So the amount of water that is used from this tank, it is 15.625 minus 8.125 meter cube, that is equal to 7.5 meter cube. So this is the amount of water that is used from the